Hi, I'm doing this video again because I made a mistake and I just wanted it to upload it hopefully before the exam time that we have today. Or for anybody who goes through it in the future and wants to refer to this video so we don't make the same mistake. It says in preparing for the upcoming holiday season, Fresh Toy Company FTC designed a new doll called the Doggy that teaches children how to dance. The fixed cost to produce the dolls it's 110,000. So here's my first value. I'm gonna go ahead and key it in. Okay, the variable cost, which includes the material, the labor, and the shipping cost, is $33 per doll. Because that's my variable cost. During the holiday season, FTC will sell the dolls for $41 each. So $41 each. If FTC overproduces the dolls, the excess dolls will be sold in January through a distributor who has agreed to pay FTC $9 per doll. So the surplus is going to be $9, whatever is left over. Demand for the new toys during the holiday selling season is uncertain, right? That makes sense. The normal probability distribution with an average of 70,000 and a standard deviation of 14,000 is assumed to be a good description of the demand. So assumed to be a good description of the demand, so that is a sign that that's our demand. FTC has tentatively decided to produce 70,000 units. So production quantity 70,000. That was one of the errors I'm pretty sure that I made last time. I referred this to the demand since it was the same number, but as the professor was explaining to me, when we do the one-way data table in part C, it's going to change. And so that's why it was giving me an error. So we hard-coded that. We need to hard-code that. So the next thing that they ask us is for a sales quantity. So if you click in here, she said it was the minimum lowest value among the demand and the production quantity. Again, the minimum value between who? The production quantity and the demand. So my revenue from sales are going to be the whatever we sell times, right, the price that we sell for. That's revenue from sales. My surplus is going to be whatever we produce minus whatever we sell. And that'll be if there's anything left over. In this case, there's nothing. All right, my net revenue from the surplus is going to be whatever it was left over times the surplus price, enter. And if this confuses you because this is quantity, this is not money, this will be the money, the revenue from the surplus. So I'm going to change this into number. Okay. Now, total revenue. So my total revenue is going to be whatever revenue from the sales plus whatever revenue we got from surplus, if we had any. Now, here's what I had the trouble with the total cost. So hopefully, whatever she said it was, it makes it correct for me. So it's the production quantity times, let me put parentheses. So equal to parentheses, my production quantity times who? My variable cost, right? What it takes for me to make, what it cost me to make the doll. And then I'm going to close it and I'm going to add who? My fixed cost. So fixed cost is not going to change. It's going to stay there no matter what. I'm going to click enter. All right. And so my net profit is going to be my net revenue, total revenue minus my total cost. That should be my revenue. So here I didn't have a problem because either way that I was doing this total cost, it was still giving me the same answer. So we should see, because it's this part down here, the one that I was giving me trouble. So let's read part B. So create a two-way data table to compare the net profit using production quantities of these production quantities, right? And these type of variable costs. So they want to know the profit if I produce 40,000 and my variable cost is at 30, how much is going to be my net profit? Basically is what it is. So what is it going to change here? What is the net profit for variable cost at 32? Variable cost, 32. And a production quantity of 50,000 units, so 50,000, right? Assuming that the sales price will be increased to 45, So I'll go here, sales price, 45. And while the average demand, so let's go one by one. Average demand is going to be the same. So I don't think there will be a problem referencing that. You know what? I'm not going to. Sorry. All right. And average demand and other parameters will remain the same. So what else was not given to us? The fixed cost, it was 110. And then my surplus price was the other one that was not given. So it stayed the same, $9. Okay. Now here for sales quantity, what did we do at the beginning? Same thing. It's going to be the minimum between this one and this one. Now we have a difference, right? This is less than the demand. My revenue from sales is going to be the same formula times now my price, which is going to be different. My surplus is going to be whatever I produce minus whatever I sell. Again, nothing here. Then my revenue from the surplus is whatever I extra produce times whatever we sell it for. Enter. My total revenue, it's going to be revenue from sales plus the revenue from my surplus. Go ahead. Again, total cost. So we're going to do the same thing. Total cost is going to be whatever I produce times my variable cost, right? And then I'm going to add that to my fixed cost. That should be in total whatever I spend doing the 50,000 units. So my net profit is going to be revenue from sale, total revenue minus the total cost. Now to do this two-way data table, first thing we're going to do is we're going to reference the net profit. Why? Because they're asking us for the net profit. So in order for us to select this two-way data table, this is the way that I interpret it. So I'm going to select the table. I'm going to go to data, what if, data table. This was the data tables are a little complicated for me. The way I see it is that since these are rows, right, these represent who? My variable costs. And it all goes back to this model right here. We're not referencing anything here. So row input, like I said, who's my row in this table? My variable costs. And then who's gonna be my column right here? My who? My production quantity, right? That's what they say, my production quantity. So I'm gonna hit OK. I don't know if this is correct, so let's go back to answers. Question A, yeah, so far so good. Yeah, because it's asking us for production quantity. So again here, what is the net profit for variable cost of 32 and a production quantity, right? It says create a two-way data table comparing the net profit using for production quantity. So if these are production quantity and it's in my column, that's going to be in my column in the two-way data table. If this right here is going to be my variable cost and those are rows, that's going to go in rows since it's a two-way data table. Okay, well, I think I got it. Okay, that's part C. Part C, here's where I had the problem. Using the model developed for part A, so this one right here, I create a simulation model demand as a normal random variable with a mean of 70,000, so it's already hard-coded here, and a standard deviation of 14,000. Simulate the sales of the doggy dough using a production quantity of 70,000 units, and that's why we're referring to this because we had a production quantity of 70,000 units. All right. So here, to calculate the demand, we're gonna use the formula norm inverted, since it's given to us the demand and then the mean and the standard deviation. So it's gonna be the probability. So she was kind enough to give it to us, comma my mean. I'm gonna anchor it so when I drag it down, it doesn't move. Comma my standard deviation. Again, anchoring it. I'm gonna hit OK. All right, so I'm gonna go up and double click this net profit. So here's what I'm gonna go ahead and do my one-way data table. And my net profit, I'm gonna go in reference to who? The net profit. And part A, production quantity 70,000 units. Go ahead. And now, like she explained it to me, since we're talking about demand we're going to reference back to the demand, not the production quantity. But let's go here. Let's first select the table. So we're going to scroll. Okay, select the whole thing. I mean, the table that we're going to analyze. What if data table? Again. So do we need to figure out anything this way? No. We need the column, the net profit column. And that's why nothing goes in rows. We're going to fill out column. And we're going to fill out column depending on what my demand. So depending on this demand, we want to figure out the net profit, which makes sense to me at least. Hopefully, this is like she said, so hopefully we get it right. When I give it okay. Okay, I think it is. Average net profit, so this is pretty standard. Average of my net profit, they're all referring to the net profit. So I'm just gonna go ahead and average net profit. If anything, if you don't have not watched any of my other videos, there's an easier way to do it. You select the column on your table and you go to formulas. You go to define a name and let's put net profit, just net profit. I'm gonna hit OK. And so for example, when I do here, go my maximum. So I'm gonna hit max, and instead of selecting the whole thing, I'll do net profit. You see it shows right there, and it already selects the column. So it's easier for me to, well, also in the future, when you go back, you're like, what is this talking about? If you have like a huge table with rows and rows and rows and columns, and it's easier, oh, I'm talking about profit, I'm talking about cost, I'm talking about whatever it is that you're referring to. Minimum of, again, my net profit, and then enter. And then my standard deviation. Again, if you have not watched any of the other ones, standard deviation is just the difference, how the gap in between the values. So net profit. So these values are approximately 300,000 apart, $1,000 apart. So let's go to answers. I think this is right. Yeah, this is right. 100%. So if you have referring to this in the future, or for whatever we have a test today, good luck. I think we got it this time.